Hello, everyone. I hope you're doing well today. My name is Sean Donaldson, as you can see there. I'm with the Alliances team at BitDefender. I've been there for about 8 years. If you hear me say a couple of things funny, it always cracks up Kurt. It's because I'm from Ottawa, Canada. So I'll try to avoid saying about and words like that, because it tends to confuse people. And to my right is...
Thanks, Sean. Hi, everyone. I'm Kurt Romer, Chief Security Strategist with Citrix, member of our CTO office, and really happy to be here this afternoon. We got a lot of interesting things to talk about. Been with Citrix for 13 years now, and looking forward to you tweeting this session. This is open content, and we'll definitely get you a copy of the presentation afterwards as well. So, Sean and I thought that we would do this session with just one slide. All right, we're done.
All good?
Thanks.
Yeah. All right. Oh, we should do more. Oh, okay. All right.
They probably want a little more detail.
So the agenda, of course, we did the introduction, so we don't need to go through that. We're going to very quickly go through the web threat landscape. It should not be anything terribly surprising. The web is an interesting place. Kurt will cover how browsers should be thought of not as applications necessarily, but more how they can be viewed as frameworks. I'll talk about how isolated browsers, and we'll cover what isolated browsers mean, also need to be secured, and then how that actually works, what the underlying security that we're applying in browser isolation, how the actual mechanics of it come together. And then bring it all together, see how it works in action. There is a recorded demo, and what to do next. So very quickly, this is one of my favorite quotes. I don't often quote analysts, no offense to any analysts, but this was from a Gartner report, and literally the first line in the report was, "The web is a cesspool." And I sat back and said, I'm going to enjoy this report. And indeed, it was a good thing. Now, in today's everything as a service world, one of the challenges is so many of the productivity apps are today accessed via web browsers that are sometimes used for other things as well. Users, on the other hand, we can educate them as much as we want, and indeed, we can't blame end users. They will click on things. Attackers are very good at fooling end users, even sophisticated end users. And none of what I've said so far should really be as interesting as those models make it appear. What we're here to talk about today is that there is a better way. You can increase the security of the browsers and the plugins. They happen to be a cesspool on their own, and not isolate your end users from the web's resources, which they demand access to. And beyond that, not increase the workloads of admins. So first, very quickly, the threat landscape. These are the vulnerability trends over the last 10 years, from about 6,000 to 16,000 over the last decade. This should not be a surprise. More code, more vulnerabilities, better techniques for fuzzing and finding vulnerabilities. 2019 so far isn't looking any better. This is from NIST. This is a really interesting one. It covers the types of vulnerabilities being exploited over time. If you look at the far right, you'll see buffer errors and code injection. So two memory manipulation techniques. Keep that in mind. It comes up later.
Yeah, it's interesting as well, this latest Intel processor vulnerability that was announced within the last week can also be executed from within a browser. So from within user space, it's crazy.
And guess whose researchers found that?
Yeah.
Yeah, shameless plug. So within the threat landscape, and at this point, we are beating a dead horse with this vulnerability information. But we know web browsers are always at the top of the list. I don't know how exhaustive this is. Like, how would you go through every version of every plugin out there to compile this sort of list. I mean, we all know intuitively from our own experience, a lot of the time attacks are coming in through browsers and plugins. Very familiar attack scenario. If this looks surprising, as it says, kindly contact the authorities. So this should be very familiar. It's pretty rare for attackers to send malicious attachments. They always send, I shouldn't say always, they often send URLs now. That way they can manipulate the attack code that lives on the server that they're controlling. As soon as something gets detected, they'll start fiddling with it, change it, and essentially the same link will work. When the end user inevitably, an end user somewhere will click on the link, that launches an exploit of a vulnerability in their browser or the plugins. If the attacker does that successfully, they gain remote access. That's how they get the initial foothold. What they do at that point, they could inject ransomware, they could drop command and control, they could do a completely fileless attack where they never write anything to disk. They just start attacking the next system over, on and on and on. The bottom line here is this is how, in one scenario, they can gain that initial foothold on systems. This is what the demo will look like. So from the user view, it's essentially, here's a link. Of course, you know, we stick a pretty innocuous looking link in there. They're getting really sophisticated, using characters from different alphabets that look kind of like characters in the alphabet that we use, but are different, and on and on and on. They're getting really, really good at this. So over to you, Kurt.
Yes, little primer, a reminder as we go through this. What do people actually use browsers for? Well, most of this should be rather obvious. Got the ubiquitous cat videos. We've got Facebook and other social media, also great ways for malware to be injected. Some not safe for work content. See a lot of that happening, and that can cause legal issues as well as other problems.
I thought we were going to update that graphic.
Yeah.
Okay.
Legal changed that. Webmail, of course, and other communication and collaboration technology. Arbitrary links oftentimes will lead not just to shopping sites, but directly to ransomware and phishing and other things. And then we also have increasing amounts of business applications that are driven through the browser. And on top of that, also the web consoles behind them. Anything that you do in the cloud is by definition through a browser. All of your cloud administration is through a browser. Increasingly, everything you're doing as a highly privileged user is through a browser. See the problem? Well, we're going to explore that a little further. Little further expansion on what businesses are using browsers for. I'm sure you could add substantially to that list. Don't just think of these as use cases that are lumped together. Think of these as use cases that demand a different level of security or different security methods or different verifications. How would you audit access to each of these? How would you go through and investigate an incident? Go through and look at threat retrospectives. If you're just letting people run the browser that's on their laptop or device, how can you go through and control any of these very critical functions, and how can you audit them? So don't think of use cases just as, yeah, we need to let users use them. There's a lot of administrative access back behind it. And the browser also is almost always completely overprivileged and overconfigured. Your browser is set up to get to any type of resource, use any certificate from the US, from Canada, from any place else throughout the world. It's got all the browser frameworks and plugins and everything else connected into it. It's connected to your registry. It's connected to your file system. It's connected to your key store and your password stores. You know, think of all of the things that we have munged into the browser these days. It is definitely overprivileged and overconfigured.
Downright promiscuous.
Absolutely. Right. So that's one of the things that we definitely need to solve. And I'll lead you to read the rest of these, but one of the big things we're going to focus on is control over resource delivery through the browser. Don't just think of the browser as an app, as Sean said. Think of it as a framework, and a framework for delivering resources. So what we're going to do is spend a couple minutes talking about delivering resources through browsers. And in order to do that, I want to introduce the 4 primary delivery methods. So if you're delivering any resource, you have 4 predominant methods. You can go direct to the resource, also called native access. Pretty easy. Somebody just pulls up their browser, they go to their favorite SaaS or cloud app. There's no intervening proxies or technology or filtering or anything. It's just them going to the resource. Is that appropriate? Of course it is, but not for a high security context, right? Might be good for YouTube or for training or stuff like that. But the second method is proxies. So you've got forward or reverse proxies. They do content filtering, scrubbing. You can do rewrites, redirects. See some applicability with the browser there? Yeah, there's a lot that a proxy can do with browser-based functionality. And remember, proxies are not just networking technology. Proxies can be in a lot of places. You can have a proxy framework embedded in the browser, and you can have proxies as part of your workspace and as part of cloud services. So don't just think of them as a piece of kit on the network. The third method for delivering resources is virtualization. And particularly with the browser, being able to virtualize your browser gives you a lot of functionality you otherwise wouldn't have. Today, if somebody went home and they were running Office 365 or Salesforce or Concur or Workday, one of the very common apps, how do you control their ability to print information to a printer and whether they can print their personal info, but maybe not info that is related to customers or their teams or things that would involve intellectual property? How can you control their clipboard? How can you control where they save information? How can you control whether they can utilize other peripherals within the environment? And even if the webcam and microphone aren't needed, turn them off by default. Well, with virtualization, you can very easily do that. And that's why we see a lot of people using virtualization in a browser context. And we're going to show more of that here in a second. And then the last deployment method is containerization. So the ability to have a container, and when you hear containers, don't just automatically think Docker and Kubernetes. They're very important. You also have mobile-based containers. You've got project-based containers. Containers are used for offline access. They're used for delivery. They're used to help control deployment of resources. And we're going to increasingly see the browser used within this context. So it doesn't matter what type of resource you're delivering, you're using one of these delivery methods: direct, proxied, virtualized, or containerized. Now, these used to be something that you had to pick when you were architecting the application. The nice thing is, with the workspace, you can dynamically pick these at the point of service. So if somebody's in a different situation or there's a different risk level, you can pick the deployment method that makes the most sense for them. So utilizing situational awareness, you can make sure that all access and usage is risk appropriate by using a combination of these methods. Let's take a look at that from a browser perspective. This is a little bit of a busy slide, but we did that on purpose because browsers are not just an app. They're very complex, and they really need to be considered as a framework. On the left-hand side, you've got your local browser on the endpoint. All of us have browsers on many of our endpoints and many of the devices that we work with. There are times when it's appropriate to use that, but remember, oftentimes that local browser is overconfigured and overprivileged. And especially for things like privileged access and administration, you don't want to rely on that. There's too much risk in using that browser by itself. You also have a lot of options for containerizing a browser on the endpoint. We've seen things like Chromium. You've got Microsoft and what they're doing with the Edge browser and embedding Chromium in there. Even the Citrix Workspace app has an embedded browser as part of it, and you can consider that as a containerized browser. So increasingly, you've got ways to make the browser much more specific, even as it runs on the endpoint, and may be able to do some things offline. In the middle are a lot of the resources that would be published through the data center. So you can deliver any of the types of browsers that you would need on Windows, on Linux, and we'll talk about the special HVI thing here in a second. And then way off on the right, you've got cloud-hosted browsers. You might think, why would you want to host a browser out in the cloud? Well, you may have some non-strategic traffic that you just don't want on your network in the first place. You don't want it going across your network, you don't want it on your endpoints, you don't want it hitting any of your logs, but you need to use it. Examples are things like social media, where maybe you want to give your employees and contractors access to social media, but you don't want it actually coming within the four walls. You want to keep it outside. Might be good for investigations by the security team, where they have to click on one of those bad links or something that's suspect. Launch it out in the cloud so it never touches your infrastructure. We've also seen this used in areas where you cannot do content filtering, like libraries and prisons and other things within the US, where you need to provide the service, but you really don't want that to be on site. You don't want it interacting with the machine or the network. So cloud-hosted browser, very, very interesting. And there's a lot more on this slide that we can get into, talking through a lot of the various aspects of whether you're going direct, whether you're going containerized, whether you're going virtualized, or whether you're going through a proxy. So when you think about browsers, think about all the different ways that you can deploy them and the benefits for usage and administration. And then we get to the fun part that Sean had to make sure is going to flash on the slide, HVI.
Yeah, just at least I didn't find the blink tag. So yes, hypervisor introspection. This is really where we're, when you think about the four pieces of the framework, we're concentrating on virtualized browsers here. And the reality is they're isolated. They're not running on the end user system, that's good. That's really good. But they're not necessarily secured. So a browser running within a virtualized container, basically Citrix virtual apps, I'm probably going to say Zen app. Did they change the name again?
I don't think that'll offend anyone.
Okay, yeah. All right. Sorry, my little Citrix joke. But although it's running in an isolated session, it can still be compromised. And so the question is, and this is a direct parallel to non-persistent VDI, what are you willing to sacrifice during the period of time that that is compromised until it's destroyed and reinstantiated? East-west attacks, obviously, if an attacker has gotten onto the low-hanging fruit, they're after something else, or potentially are after something else. So they're going to use that as a foothold in the environment to move on to other systems. So even if you can reset that system, the attacker may already be on another box. Also, and this goes back to conversations with kiosk vendors years and years ago, okay, it's compromised once and then every night at midnight you reset the thing. So that means you're willing to sacrifice being compromised for 11 hours, 59 minutes a day. That doesn't really sound ideal to me.
No, it's funny you bring that up, because you see some developers these days relying on that old kiosk model, putting the browser for microservices in a container and just refreshing it when things mess up. That can cause problems too, right?
Oh, absolutely. And we know once an attacker can get in there, they'll just keep doing it over and over again. So what is hypervisor introspection? This is just a quick overview of it. We have the Citrix hypervisor down at the bottom. If you guys are into the Zen project, there's something called virtual machine introspection that has been in there. We at BitDefender put a lot of work with the Zen project folks into extending that, essentially putting it on steroids. As it's been rolled up into the Citrix hypervisor, the commercial name is Direct Inspect APIs. What does that mean? What that is it gives our security appliance, and this is an open API. Anyone can code against this. Any security vendor can. It's only BitDefender that has done so. Our security appliance essentially can access the raw memory of running virtual machines without having to touch those virtual machines. So we're running outside, and due to the access that the hypervisor gives us, we can see everything that is occurring within the memory of running virtual machines. So pretty cool, and there are some implications about it that we'll briefly cover. I could go on all day just about that piece. But essentially what we're looking at is if somebody attacks a virtualized browser or any virtualized instance, we see that. we get the alert. We know what is happening. We can block that. We can report on it. We can even, if we want, inject cleanup tools and get rid of that problem. Now, the cleanup tools, that's really overkill. Again, we're looking at the point of exploit. If we're blocking the exploit, the attacker doesn't get that initial foothold on the system. Injecting cleanup tools is a way to say, okay, we know something's going on, let's just be sure, let's basically look at the entire system in a more traditional way. How does this really work? How does it actually detect these things? So quite often, because BitDefender is known mostly as an anti-malware company, please don't say antivirus, that offends us. As an anti-malware company, people go, oh, okay, so this is anti-malware at the hypervisor level. It's not. We've taken a very different approach. So essentially, first, what's it based on? I mentioned VMI. Under the hood, it's using Intel extensions. So this is going right down to virtualization instruction sets on the silicon. And it allows third-party appliances to get privileged access to memory. The appliance itself is running in a privileged space. Essentially, we register rules with the Citrix hypervisor that allows us to trap certain events. So what do I mean by that? And I'm simplifying this to make it human readable. Essentially, here we're talking about a buffer overflow. So somebody forgot to do bounds checking. You stuff way more data into a certain parameter than should be there. That means you can write memory that is beyond what should be allowed for that particular parameter. And if you do it right, you can execute something. So essentially, what you're doing is you're overrunning the buffer in heap to execute your code. Again, most of the time, you're probably going to crash the process, maybe even crash the box, but attackers have all the time in the world, don't they? So eventually, if they get it right, they can take advantage. Now, what we're doing with HVI is we're saying, hold on, that particular piece of memory is read-write. Why is something trying to execute on it? We don't care what the vulnerability is. We certainly don't care what the specific exploit is. We just know someone is trying to commit a memory violation to produce unexpected results, i.e., in a buffer overflow case, the ultimate goal is to run code on a system, remote code execution, and gain control.
So you said we don't care what the exploit is, we don't care what the vulnerability is. I bet there are a couple people who care. Anybody in here have folks within your organization that develop web apps or contractors you hire to develop web apps? Wouldn't it be kind of cool for them to have this, to be able to take a look at what's going on, debug the application, be able to get the running state, and even when it's crashed, be able to reset it instantly and then try the attack again and see exactly what's happening as they're live making modifications to the code. From a developer perspective, this is tremendous. How about security teams? Anybody in here from a security team? Yeah. So what if you've got something that is coming in that you know is causing major problems, but it's not being highlighted anywhere? You could redirect it over to this system, and because of in-memory forensics, be able to see exactly what is being targeted against your organization, be able to see why it's unique, and be able to develop some mitigations for it. These are a couple things that most people don't talk about, but I see as being a very core value, and Sean does too. He just wanted to say, people don't care. They do care. That's why we wanted to make sure you saw this on the slides, because the applicability is not just BitDefender's got some really bright people and they can go through and help to look for any in-memory violations. It's that this technology can be used for so much more than just security incidents and malware.
Absolutely, absolutely. And there is good forensic data that gets pushed out. But certainly the point of not having prior knowledge of the exploit or the vulnerability is something that our customers enjoy. When WannaCry first started hitting, we weren't that surprised, because as soon as we saw Eternal Blue come out, the first thing we did was say, hey guys, HVI will block this, right? And they said, oh yeah, it's got a buffer overflow. Yeah, it definitely does. We published a blog post. 3 weeks later, WannaCry hit. Our customers who were running HVI kind of went, Wanna what? Right? it could not spread across their networks because they had HVI installed. So it's having no a priori knowledge of the exploit or the vulnerability, just seeing it's a buffer overflow, I'm going to stop it. That means, going back to, it's not anti-malware at the hypervisor level, we're looking for attack techniques. Attackers use the same techniques over and over again, and this is so much more efficient than looking for known bad or trying to whitelist known good. Those are valid approaches, but we all know they have their limitations. Attackers only need to succeed once, whereas defenders need to succeed every single time. So if we can take these attack techniques out of their hands, buffer overflow, heat spray, code injection, function detouring, there's a whole bunch more, but I'm not going to go through an exhaustive list. We're really raising the bar on the cost of attack. If they can't use buffer overflows, that's really painful for the attacker. Another piece is this security is actually isolated from what is being protected. So because the virtual appliance is running at a higher level of privilege, and obviously where we're getting the information, the hypervisor, is at a hardware enforced higher level of privilege, that means we are isolated from what is being attacked. When you're running within a VM, what is the first thing the attacker does? Turns off the security or otherwise obfuscates itself to hide from the attack. We see that all, and we're not affected because we don't have a footprint within the VM to attack. So this is really bridging the gap between context and isolation. That's another concept I could go on and on about, but let's just say a classic security problem is my network IDS, IPS, or my web app firewall is painful to configure because it has zero contextual awareness of what's going on within the VMs, whereas if I'm in the VM, I have great contextual awareness, but I have zero isolation. So I'm susceptible to attack in the same way everything within that VM is susceptible to attack. And indeed, I'm using OS APIs within the VM to protect the OS APIs within the VM. So this is a great way of getting complete contextual awareness, but still being isolated from what is being protected.
Yeah, I would say as we're getting into the demo, one thing to keep in mind, Sean did show that this is any workload that would run on top of the hypervisor. And so you've got tons of different workloads, current applications, older applications that can't be patched and updated. You can run a browser server on top of it. And that's one of the main things that we're talking about here, is being able to run a browser server and being able to do redirections from email, arbitrary links, from just people who click and open up a browser, open up Facebook, click on the link for Salesforce. You can have it go to this service and have it be able to protect at the levels that Sean was just talking about and what you're about to see in the demo. So we're focusing on web browsing today, but there's a lot more that you'll want to stop by and see later.
Absolutely, and I've seen a lot of very worried admins, especially healthcare, finance, places like that, who have to publish IE6. Like, that must really, lead to some 2 a.m. sweats. So let's see what this thing looks like in action. There we go. So BitDefender browser isolation, which is a specific solution running on top of virtual apps. So, of course, little thing from Ponyman, they always like to throw big numbers out there. Again, no surprise. We know web browsers are a problem. So there's that user view, attacker view. You're going to see some, welcome to the matrix stuff. The bottom line there is when they clicked on the link, they talked to the web server. Now the attacker is running within the context of the Flash player, and they have full admin on that box. You can see that they just downloaded secret docs. In that case, they're just pulling information off. They're never going to write anything to disk. So what is there to look for? The whole problem is the end users are running browsers within their endpoint. So that means that entire endpoint is infected. Now, again, but with browser isolation running with hypervisor introspection, they didn't get a session, right? The best security is exciting because nothing happens. So again, we're wrapping those virtualized browsers within browser isolation, applying unique security, unique capabilities of the Citrix hypervisor to protect those browsers in ways that are not possible with other approaches.
Yeah, and this entire exploit, you could have perfect hardware, perfect OS, patched and up to date, perfect browsers running on there as well. This was a vulnerability in
Flash.
Wow,
Yeah.
a plugin.
An Adobe vulnerability? No.
No, never seen that.
And as Kurt mentioned, really what we're talking about with most admins is saying, hey, okay, you're running on a hypervisor that is not Citrix hypervisor. That's the reality. And I've had admins go, well, you're nuts if you think I'm going to move this entire thing onto Citrix hypervisor. And our message is, well, let's first talk about isolating the browser execution. You're already doing that. But let's talk about the most vulnerable end users. Maybe it's people in HR departments because they're dealing with a lot of inbound stuff, a lot of PDFs, a lot. I don't think people are sending many Flash resumes these days, but you never know. Web design is a crazy, crazy place. So they are very vulnerable. Folks in finance are very vulnerable. Mahogany Row, the C-levels. Perhaps if it's a large manufacturing, there could be intellectual property, things like that. There are users and there are situations, and this goes back to the framework, where in certain cases it's appropriate to have those users' browsers or specific browsers or browsers that are accessing specific resources do it via this setup, via browser isolation running on top of XenApp. Another advantage, which I covered, is you gain context without sacrificing isolation. And that don't sacrifice isolation works both in the context versus isolation security dilemma, which this resolves, but it also works in the end user dilemma. Not every end user needs to access Facebook, but they do need to access a lot of resources out there that you don't own, you don't control, you cannot trust. And then they're also accessing your internal resources, which you own and you hope to protect with potentially the same browsers from the same systems. So you need to allow that access. Don't isolate the end users, but isolate and secure where those browsers are running. How do you get started? It's pretty simple. We have a management console. We call it Gravity Zone. Of course, at BitDefender, we do a whole lot more beyond browser isolation. But within Gravity Zone, our management console, you just add Xen server. That pulls in your hierarchy, your inventory, and the whole structure that's in there. Set up an HVI policy. In this case, it's pretty straightforward. What applications do you want it to apply to beyond protecting kernel memory? And by the way, if you have other security tools running within these instances, we protect the drivers that run those security tools. That's just another checkbox for us. Obviously, in this case, you'd be going with protecting browsers, and that's really it. It's pretty straightforward. I think the biggest step is planning it out, figuring out which users, which URLs, which browsers do you want to be published in this high security browser isolation environment, and planning that out. The actual implementation, standing up a couple of Xen server instances and configuring Gravity Zone and hypervisor introspection against them is, a morning. It's not difficult.
Yeah, not at all. In fact, we've got a joint white paper that we developed that goes through in detail how to do this, what are the considerations, how to configure the environment. And as Sean said, even if you're running VMware, you're running Hyper-V, you're running another hypervisor, it's very simple to stand up Xen server for just this type of solution and be able to utilize it within the other environments. From a key takeaways perspective, we wanted to make sure that you were thinking of some of the areas that would benefit. Your highly privileged users, people who have privilege within IT, within your security organization, your network administrators, the people who manage your certificates, hold the SSH keys, but also privileged users that exist in other parts of the org, legal, HR, people who are privileged who are outside the organization. Maybe you have suppliers coming in and you're really concerned because you don't own the systems they're coming in from. You want them to hit a very pristine browser, and you want to make sure that as they're getting access, maybe even through email or another collaboration platform, that any link, any file that happens to have embedded URLs, any image that happens to have embedded URLs is handled appropriately.
I've even heard about the reverse case where you own the application, but you don't trust the systems that your end users, external end users, are accessing your application through. So you basically provision to them Citrix receiver, and they're accessing via a remote browser that you're protecting. So you don't care about the security state of grandma's computer that is being used to access your very sensitive application. So it can also be on the inbound side.
Mm-hmm. Yeah, and from an arbitrary links perspective, within the workspace, you can obviously redirect those arbitrary links, do URL filtering, do IP reputation. You can go through and do content scrubbing. You can launch it in a virtualized browser, cloud-hosted browser. You can also have your arbitrary links go over to HVI for further inspection. And as you've heard, even if it's something brand new that nobody else in the malware community has seen before, if it causes an in-memory violation, you're going to see it. You're going to be able to snapshot it. You're going to be able to stop it, which you probably want to do, remediate it, and you're also going to be able to go through and perform some forensics against it. And that's why I say this is also very appropriate for security teams, because in addition to the protections, you get a lot of visibility you otherwise wouldn't have. It helps you click on those links where you've got to look at something from an investigative perspective, and you don't have your Chromebook in front of you or something else that you can trust at a pretty high level and would otherwise reset. And to me, one of the other core areas is developers. This gives a lot of very rich information to developers. And as they're continuing to develop browser-based apps, mobile apps, a lot of microservices, funnel it through HVI so that you get a much better picture of what's happening. Maybe there's something that the OS just kind of stumbled over, it tripped, but you never really saw it. It went into a log somewhere, or maybe didn't, and it's something that might be a problem later on, a very, very slow leak, for example. This is going to show it. Other solutions are not going to give you that level of visibility because it's looking from outside without any guest agents. So that's why we're pretty excited about it. We've got a lot of great customer success stories and happy to share those.
Absolutely. So I guess in closing, before we get to the Q&A, and they've requested, please use the microphone because the audio is being recorded, so we don't want your question lost. Come by the booth. Anyone not know where the BitDefender booth is? It's a good-sized booth. Okay, I'm glad to see that. I don't have to escort anyone down to the show floor right now. But yeah. Seriously, it is a good-sized booth. Stop by. We have a lot of people who are much smarter than I am at the booth who can answer any in-depth questions that you have. And you can also explore all the other fun stuff that BitDefender is doing beyond hypervisor introspection and the browser isolation. So with that.
Questions?
I think we either confused everyone.
They just appreciate getting done early.
Yeah.
Brian Mann.
Yes. So we always hear about there's so many tools out there and so many security vendors, and you're bringing another solution in that could add complexity, right, which then could lead to more risk. Where could you reduce that? Where does this reduce the complexity? Is it on the network side? Is it on a different malware protection side? Where is that reduction in complexity due to maybe show more value of this solution?
Absolutely. So the most significant area is that this is an entirely different approach by leveraging the hypervisor. And this is something, I've always been kind of curious about this because as virtualization has taken over the data center, I expected that there would be a lot of security vendors looking at the stack and going, how can we actually take advantage of this rather than how do we re-architect anti-malware to not have such a huge performance hit, which is what many have done. So really, it's a brand new approach. but it is complementary to the existing approaches. So we're looking at memory with this. Within an endpoint, you still want to do file system scanning, for instance, but we can protect the drivers within the endpoint that are doing the file system scanning. So I wouldn't look at it as adding more complexity. It is certainly another layer of security that is protecting things that are higher in the stack, directly complementary, though. So I wish I could say, hey, you could rip out all these other security solutions and just use this, but as a security guy, if anyone ever says that to you, just shake your head and say, thank you for meeting with me, and let them go.
Yeah, the other solutions are there for a reason. Maybe you're in a PCI environment, you have to have them.
Indeed.
But this does give you some additional tools. Where else are you going to get this level of browser protection? Where else are you going to get the visibility into memory events? Where else are you going to be able to redirect arbitrary links that otherwise were tripping up others? It could also be a fun tool to go through and test some of your testing tools in your QA and some of the other anti-malware solutions out there to be able to see here what's getting through, what's not getting through.
Anyone else? Going once? Going twice?
So does this also support published virtual desktops as well as virtual apps?
It does, yes. We have a specific solution because the use case for around browsers is quite simply so compelling, and people absolutely, they understand it. And so we have a specific, let's say, solution for that. The underlying mechanisms are basically the same. The broader hypervisor introspection solution, yeah, whether it's databases, VDI instances, and so on and so forth, you can apply protection there.
Thank you. All right.
Is this agentless, or is there an agent that goes on the VM?
Oh, I love that question. I love that question. Okay. So agentless is a really great marketing term that VMware came up with. What it really describes is re-architecting anti-malware. So to say, instead of putting a full anti-malware instance in each and every VDI instance or virtualized instance, we're going to pull off as much as we can and run it a single copy within a virtual appliance that really does the scanning. So it has the engines, all the threat intel, and all that. There still needs to be a communication point, file system drivers, and a few other things. But you've taken out all the heavy stuff that needs to be updated a lot. So that gives you tremendous performance benefits. But there is still something that needs to be in there. In the case of VMware, it's embedded within VM tools. They say agentless because from a security vendor perspective, you don't need to necessarily install something within the VM. Every security vendor does ultimately layer something on top. So it's agentless from the perspective of the security vendor doesn't necessarily have to install an agent, but there's still a piece there. BitDefender happens, we do integrate with NSX, including -T. We also have a version that is agnostic of the underlying hypervisor, in which case that tool set, the file system drivers, and the communication point are BitDefender software. So there's still a small footprint in there. Hypervisor introspection, on the other hand, there's absolutely no software footprint within the VMs that you're protecting. So anytime there's a memory call within a VM, the supervisor, the operating system says, hey, I'm going to talk to what is actually virtualized hardware, which is the hypervisor, and it says, I'm going to actually do stuff in the hardware layer. We're down at that layer with our inspection, so we can see everything that goes on within the VMs without having to touch them. So completely isolated, but still with that contextual awareness. Thank you for that question, because I love sort of blowing up the agentless marketing term. It's great marketing, though. Kudos.
Well, thank you very much, Sean, and thank you all for attending. Enjoy the rest of Synergy, and stop by the BitDefender booth. There's a lot more that can be shown.
Take care, everyone.
Thank you.